welcome to this video. So in this video I'm going to discuss question number 7, 8, 9 of KCET 2019 chemistry. Alright. So question number 7 is, which of the following can be used to test the acidic nature of ethanol, right? So ethanol, you know what is ethanol? CH3 CH2OH. It is an alcohol, right? So acidic nature means what? It should give this H plus, means it should convert to CH3 CH2 O minus and H plus. The molecule which gives H plus is called as acid. So it has to give this H plus to become acid, right? But we know that this alcohol is very less acidic, means it doesn't give only H plus because it is very less acidic. So to remove this H plus we should add strong base. We should add what? Strong base, because strong base can only take H plus from less acid. Strong base can only take H plus from this weak acid, right? Very less acid means what it is? It is weak acid. So to remove this H from weak acid, we should add what? Strong base. And we know that Na2CO3, sodium carbonate, is a mild base, means weak base, right? But we need strong base. So this is not the answer. Blue litmus solution, this is also very weak base and it is an indicator. So this is also not the option. Sodium bicarbonate, it is a very mild base, weak base it is. Why it is weak base? So it is used in kitchen as baking soda, right? So this is also not the answer. D is not the answer, A is not the answer, B is not the answer. The correct answer is C, sodium. So in the chapter alcohol we have studied that whenever we have ethanol, if we put sodium metal in it, there will be vigorous reaction to form CH3 CH2O minus Na plus this H plus will be released, right? So only with sodium this alcohol will react. Why? Because this metal can easily undergoes to Na plus, right? So if two molecules are there, it liberates hydrogen gas there. It liberates hydrogen gas, and this is nothing but the conjugate base. So this is how acidic nature. This is very weak base, so it reacts with more reactive metals to form this conjugate base. Sodium, uh, this salt, right? So this is the answer. Sodium metal is the correct answer for the given question. Coming to question number 8, the reagents A, B, C respectively are, right? So here this is the reaction at the left side, and we are getting three products when we add three reagents A, B and C. We have to tell which is A, which is B, which is C, right? So you have to understand, unless you know about these reagents, see, just they have given NaBH4, they have given aluminum KNO4, sorry, alkali KMNO4, hydrogen in this palladium PCC. About these reagents you should know. If you want to know, just I can write it like this. NaBH4 is there, right? NaBH4, it converts ketone, right? This is ketone to secondary alcohol, and aldehyde means here H should be there. Aldehyde to aldehyde to primary alcohol. Aldehyde to primary alcohol. So ketones, it converts to secondary alcohol. Aldehydes, it converts to primary alcohol. What? NaBH4. This alkali KMNO4 is there, right? It is a strong oxidizing agent. What it does, if any alcohol is there, for example, I have this alcohol. If I add this alkali KMNO4, it converts to carboxylic acid. In the same way, if any aldehyde is there, if I add alkali KMNO4, it converts to what? Carboxylic acid, right? This you should know, right? And what about this hydrogen in plus palladium. See, if any alkene is there, if I add hydrogen in presence of palladium, it converts to alkane. So alkene will be converted to alkane. Similarly, if alkyne is there, if I add hydrogen palladium, it converts to alkane. Right. So this is what CH2 double bond CH2. This is CH3 single bond CH3. Right. I hope you know this. Right. So alkyne is there, it converts to alkane. Alkene is there, it converts to alkane. Right. So this is the hydrogen in presence of palladium. And talking about PCC. PCC means what? PCC is nothing but it is a mild oxidizing agent. Mild oxidizing agent. What is this mild oxidizing agent? It converts aldehyde to carboxylic acid, and ketone doesn't react only. Ketone doesn't react only. Right, that you should know. Only aldehyde it converts to carboxylic acid. That is PCC. Right. This you have studied in aldehyde ketones and carboxylic acid chapter. Right. So here the given thing is they have given this one CH2OH, right, and double bond is there, and here they have aldehyde CHO, right, they have aldehyde CHO. Let me write it here only so that it will be visible for me here. So I will remove it all. Just a minute. Yes, talking about this question, see, so this is the given reagent, right? So I have CH2OH, alcohol, and here carbon, next to that alkene and CHO. So I want to convert this aldehyde to alcohol. See, they have converted just aldehyde to alcohol. Other things remains as it is. CH2OH, C, double bond has remained same, alcohol remained same, only aldehyde is converted to primary alcohol. Aldehyde is converted to primary alcohol. So what is the reducing agent we have to add? To reduce this we have to add NaBH4, because we know that NaBH4 can reduce aldehyde ketones to the respective alcohols. If ketone is there secondary alcohol, aldehyde is there to primary alcohol. Here it is reduced to primary alcohol by adding NaBH4, right? The first reagent A is NaBH4. Second reagent. So in second step we can see that the product is this one. The product is this one. CH2OH is there as it is. C double bond is there as it is, but here CHO. Here we have got just a minute. The product for the B is here also have got CHO. Here also I have got CHO, and here also I have got CHO. Means I have to oxidize this CH2OH, right? So we know that mild oxidizing agent we know. If I add KMNO4, KMNO4, what does it do? I get this product. See, this aldehyde will be converted to carboxylic acid, and this primary alcohol will be converted to carboxylic acid. But I don't want this product. What product I should want? I want this product. See, this product they have given. This product I want. So I want only alcohol. This alcohol to oxidize to aldehyde. So I'll add mild oxidizing agent, that is PCC, pyridine chlorochloromate. It is a mild oxidizing agent. I will add that. Right. So my B reagent is this one. Talking about C. See, in C product you can see that in C we have got this product CH2OH. Double bond is gone, single bond I have, again I will get CH2OH. I need alcohol here also, and I don't want any double bond, right? So what is the reagent? The best reagent is hydrogen in presence of palladium. Why this? Because this hydrogen palladium in presence of palladium is a reducing agent. It reduces alkene to alkane, and it reduces aldehyde to alcohol CH2OH. So this aldehyde is there, right? That is reduced to alcohol, and this double bond is there, alkene, that is converted to alkane, single bond. So the third reagent is what? Is this H2 in presence of palladium. H2 in presence of palladium. So answer is first reagent is NaBH4 followed by PCC, H2 in presence of palladium. Answer is D is the correct answer for the given question. Talking about question number 9. So it is HVZ reaction which you will learn in carboxylic acid. Right. Propanoic acid undergoes HVZ reaction to give chloropropanoic acid. The product obtained is, right. So unless you know the structure of propanoic acid means CH3, CH2, COOH. So this is what propanoic acid. Propanoic acid. To this is if I do HVZ reaction, right, in presence of chlorine, I'll get what? Chlorine and phosphor, I'll get this product CH3, CH2 was there, it becomes CH now. Here one chlorine will come and I'll get COOH, carboxylic acid. Alpha chlorination happens, alpha chloropropanoic acid I'll get, right. So this is HVZ reaction, right. So reagent you should remember of HVZ reaction, right. So I'll get alpha chloropropanoic acid, right. Simple reaction. So if you compare, see options, if you see A as stronger as propanoic acid, stronger acid than propanoic acid, stronger than dichloropropanoic acid, weaker acid than propanoic acid. So we have to compare acidic nature of this 2-chloropropanoic acid with this propanoic acid. See, this propanoic acid is acid, no doubt. Why it is acid? Because it can give this H plus, so it can convert to CH3, CH2, COO minus and H plus. So it is acid, right? No doubt. But this is also acid. It can easily convert to CH3, CHCl, COO minus and H plus. It can also be converted to acid. Whether this is strong acid or not, we have to tell that, right? So we know that one which gives H plus is acid. This is also acid. This is also acid. But one which gives easily H plus acid is a strong acid. I will tell this is the right 2-chloropropanoic acid. It is a strong acid. Strong acid compared to this propanoic acid. Why? Because it has got chlorine at second position. Once this H plus is removed, this negative charge is there, right? That will be stabilized by this chlorine by inductive effect. Which inductive effect? Negative inductive effect. It can take this electron density, it can pull the electron density towards itself. Negative inductive effect, because of which this chlorine will pull this electron density, so this H plus can be easily liberated. So it is strong acid, because H plus if we liberate, we will get negative charge. That should be stabilized. How it is stabilized? By inductive effect, minus I effect of chlorine. But here there is no minus I effect, so this is acidic, no doubt. But if we compare both two, this will be more acidic. So answer will be B, stronger. This 2-chloropropanoic acid is stronger acid than propanoic acid. So this is the correct answer. First one is as stronger as propanoic acid. No, both acidity is wrong. D option is, we can see weaker acid than propanoic acid. That is also wrong, because it has got chlorine group to withdraw that negative charge. So this is also wrong. A is wrong. What about this stronger than dichloropropanoic acid? No, dichloropropanoic acid will be much stronger than this chloropropanoic acid. Why? Because see, CH3, 2 chlorine group will be there in propanoic acid. So this negative charge will be stabilized by minus I effect, 2 minus I effect. So this will be more stronger than propanoic acid. But here they have given stronger than dichloro. This can't be, right? So this is also the wrong option. So correct answer for the given question is B. I hope this has helped you, right? Thank you.